name is Guerrero. Just submitted my PhD a few months ago. I was one of the lucky people that got to do a whole PhD on odor, and in particular in terms of biosolids management and odor challenges. And now I'm working as a research associate here as part of the Odor Laboratory and the Water Research Center at UNSW Sydney. And I was supervised by Ruth, Richard, and Ademir. And today I'm going to be talking about part of my thesis, which was on this particular part, as Ruth mentioned, was on odor challenge in anaerobic co-digestion and focusing on food substrates and food waste. So when we talk about biosolids and biosolids management, sludge is a byproduct from wastewater treatment. And before it can be reused, we have a number of steps to make it safe, and in particular, odorless, which sometimes are not great, but we can have some sort of pre-treatment, which you might have heard of, thermohydrolysis, and then biological, chemical, or physical processes. And I have a few examples there, such as anaerobic or aerobic digestion, composting, alkaline treatment, and thermodrying. And then this product is now called biosolids, and it can be reused, for example, in land application. And in Australia, we use around 85% of biosolids to land. And it has a lot of benefits for the soil, agriculture. However, this product can be deodorant, and that's what my PhD was trying to understand, of how these different biosolids processing steps would affect the odor outcome from biosolids. But today I'm going to be mostly focusing on this emerging technology, which is anaerobic co-digestion of wastewater sludge, when you add an extra waste stream, which can be food or beverage, or there's actually been a lot of research in the last decade and investigating industrial farming, agriculture, or municipal waste materials. And now it's been emerged as an alternative method for biosolids management. And a lot of this research are looking into how it affects operational parameters, or what's the, for example, risk of trace organic contaminants and different aspects of this emerging technology. But in particular, my research, what's the technology on odor? And it was the first attempt to comprehensively study odor emissions from the anaerobic co-digestion of municipal wastewater sludge with food waste and beverage waste. And the interest in this new technology is because there's been benefits observed, such as that improves digestive stability and biogas production. However, we were concerned what would be the odor impact of this process, as odor management is already a challenge in biosolids management. And these co-substrates are unsatisfactory in meeting market standards, so expired, contaminated, or damaged, designated for disposal. So another waste stream. And how the study was conducted, as I mentioned, we had different types of waste, and today I'll be focused on the food. Two pilot scale 1,000-liter digesters operating in parallel with similar conditions. One was going to be co-digested with these different materials separately, and then one control to see what's the difference in terms of impact. And then we extracted from the samples using microchamber thermoextractor we have here in the Odor lab, and then analyzed for sulfur using GC-SCG, and then 10x sorbent tube for GC-MS. And it's important to highlight that both of the digesters had achieved steady state conditions for volatile solids removal and biogas production prior to the odor emission assessment. And then we look at, in terms of odor, what we look at analytical methods. So what's the chemical composition of the odor coming out of these co-digested and control samples, but also what's the sensory impact? So what's the perceived impact of the odor in terms of human perception? And the GCMS plus ODP, so the odor detection pool, it's very useful to identify individual odors in complex gas mixture, but also evaluate their potential sensor impact. And in terms of sensory impact, we had two different types of food waste added at 10% ratio. So 10% food waste, 90% sludge. And they were from different sources. Food waste was from cafeteria leftover meals. And then food waste B was restaurant discarded food from cooking and meal preparation. And we observed that they had kind of a similar increase in terms of odor events, 8 and 7. But in particular, we're not only interested what's the increase, but mostly we're very concerned when we have a odor event that was non-detected before, and now it has been detected in this new process. And that was particularly important for the food waste A. And these modified frequencies, which we are showing here, it considers both the frequency and intensity of odor events. So these odor events that increase, they could be either they are more frequent now or they are higher intensities. And then we also look at different feeding ratios. So if we add, instead of 10%, now we have 20% feeding ratio, what would be the impact in terms of odor? And we actually observed that if we double the ratio, we actually double the increase of odor events as well. So there's clearly an impact on adding these co-substrates into the digesters to odor outcomes. But then we also looked at chemical composition, and we detected 209 volatile organic compounds. And from those, we prioritized 16 as potential odorants of concern, which we'll see in the table. And in particular, that is a significant increase. And not only for hydrogen sulfide, but other sulfur precursors. They can occur naturally in food. They can be used as food additives to preserve color and prevent microbial spillage or result from fermentation. So these precursors are likely causing this increase in emissions from the addition of food waste. And then when we looked at other sulfur compounds, we also had a high detection frequency for all compounds but methyl mercaptan. And so other non-H2S sulfur compounds can be important when assessing odor impact of co-digestion. A lot of the monitoring sometimes involve just H2S, and we observe that other sulfur compounds and other volatile organic compounds are also important in terms of odor. In particular, in terms of volatile sulfur compounds, methyl mercaptan, dimethyl sulfide, dimethyl disulfide, and dimethyl trisulfide. And just some conclusions. This is a short snapshot from the full paper that's been published, and it's part of my thesis, but the introduction of co-substrate amplified the unpredictability in volatile emissions. So we observed a higher variability in terms of emissions when we compare with the control. Likely because we have inconsistent source of substrate, the different wastes that were added, they're likely going to vary over time, and that's likely to disturb the digester. And also there might be insufficient adjustment time in the digestion processes, even though we saw steady state conditions for volatile solids removal and biogas production. And then the presence and degradation of the precursors introduced by the co-substrates. And then in terms of overall conclusions, as I mentioned, this was the first attempt to study the odor impacts of co-digestion. So before the introduction and choice of substrate mixtures, there should be further study, so carefully study before full implementation, because you can have odor, like increase your odor in problems, and then GCMS with the sensory is a valuable method to provide both olfactory and chemical information on treatment performance and nuisance impact. And by having this information can be useful when optimizing digester performance to reduce nuisance impact, because we want to make odor a operational priority, not just a kind of inconvenient byproduct from the wastewater treatment or biosolids management. That's it from me. Thank you very much, and happy to answer any questions that you might have.
Thank you, Thais. The questions will come through YouTube and the YouTube chat.
Okay.
If anyone has any questions, you're welcome to submit it via the YouTube chat. Just a friendly reminder that you will need a Google account in order to be able to ask the question. I'll let you take over, Ruth, when you're ready.
Sounds good, thanks. I'm not sure if, oh, there was a question from Bart, if Thais is still
I'm
online.
still here.
Right,
Okay.
or maybe you'd like to answer the question from Bart. It was, would there be any specific food sources that you would recommend not to add?
So I guess what we saw from our research was that first we need to further study this, but in particular in terms of food waste, I would say it was the worst outcome we had, because I didn't show the results for the beverage rejects here, but they actually improved some of the odor emissions. They reduce, but in terms of food waste, I wouldn't recommend adding them at this stage. At least we might be able to optimize operational conditions, but yeah, not from our study.
Yeah, yeah, that's great. So yeah, composition changes can be a challenge.